Hello everyone. So welcome to today's session, error and exception handling in Python. So today we'll see what is error handling and what is exception handling and why should we handle our exceptions so that our Python programs become more robust. So, what are errors? So, in your program, you might have seen while we run our program, if you make any mistakes in the syntaxes or in the logic, the program will error out. Like, for example, index out of range or indentation error, syntax error, value error, so on and so forth. So, similarly, we'll get errors in the logic also, like if you divide a number by zero, which is not acceptable, so those kind of errors you can handle it. So why do we handle errors? To prevent program crashes, provide meaningful feedback to the users like we who are running it, and ensure smooth execution of the codes. So what are the type of errors that we have in Python? So first is syntax error, second is runtime error while running the program, and third is logical errors. Okay, so syntax error is like the mistakes that are there in the code structure, and the runtime error is like that occurs during the execution, like for example when you divide by zero. Logical errors like the code runs successfully but it gives you incorrect results. Okay, so what are the benefits of handling exceptions? First, number one is it's the best practice of writing a good code to handle exceptions. So it makes your code reliable, and it makes easier for debugging and maintenance, and it gives better user experience. Okay, so let's see a simple program. I will run it. So here is my program. Age is equal to int of abc. So what I'm giving, my age should take integer value, but I'm supplying a string. So this is take for example a case of a user whom we are asking to input the age, but the user is entering a string. So this is a loophole, right? So what might happen here? So it will generate a value error. So how to handle these kind of errors? How to tell the user that you cannot enter strings in the integer type of data? So for that, I am putting my age. So whatever the code that might generate error. So I'm putting that in try block. So try block is used to is used for the code which might generate error. So it's kind of a risky code that you are putting it here, and then except clause you will write, and whatever the exception that code might generate will catch it here. For example, when we executed this code, it generated this value error. So this is the type of exception. So we'll copy this, we'll catch this and put it here in the except clause. So we are catching the error, whatever the error it might generate, as an exception type. So except clause will take exception type, and try block will take the risky code that might generate error. Then it will print the proper message instead of program exiting in the middle and erroring out. We are exiting the program gracefully. So here you can see, here the program did not error out. So what did it say? Invalid input, age should be number. So this is simple. Like, instead of exiting the program, we exited gracefully by informing the user that you have put the wrong type of data. Okay. So next we have error handling and syntax. So this is the syntax. Try block. That this is the block where we write all the code that might error out, and we catch that exception with the exception type. Okay, then we write the finally statements. Like for example, when we tried in these two steps that might have some resources we consume, if you want to release those, we can use this finally block. So these are some of the built-in exception types that we have in Python. So just now we saw this value error, right? Similar to this, we have a lot of built-in exception types that Python generates when it finds error. So we have syntax error, indentation error, name error, type error, value error, division by zero error, index error, key error. So all these error types we have. Okay, so we can handle all these error by using exception handling. Okay. We can also create manual uh, manual exceptions. Exceptions which are not inbuilt. Exceptions we define our own. We define for our programs. Those kind of exceptions are called manually raising exceptions. So, for example, see here. So what I did, I wrote a try block and I said I'm just triggering an exception. So here I don't have any logic. Just to show you I'm triggering an exception. What I'm saying raise exception. I'm using exception inbuilt function and just passing a message. This is general exception and I'm catching this exception here in except block and just printing it. So here you can see caught. This is general exception. So similarly, these kind of manual exception writing I can use to write to assign these manual exception writing to my uh, some custom programs. For example, I have a program where user is trying to withdraw an amount which is greater than his balance. So, for example, his balance is just 1,000, but he's trying to withdraw uh, 2,000. So what should we do? We should raise an exception. So the program should exit gracefully. It should not crash in the middle. So what happens is here you can see his balance is 1,000 and he's trying to withdraw 1,500. So now we are raising a manual exception. We have written here a raise exception in the try raise exception. So what is the exception? Insufficient balance. So we are calling this withdraw function here. So we are putting this withdraw function in the try block. So whatever it tries, it raises an exception here and it catches this and prints it. So it says insufficient balance. So similarly, we have syntax error. So syntax error is like every if statement will have a colon if true. So uh, there should be okay missing colon here. So it says if true, after if true there is a missing colon here. So what is this exception type? Syntax error. So for these types of syntax errors we cannot handle it. We have to correct it. So what I say, if true, I have to correct it with adding a semicolon. So these kind of error handling I have to correct it by myself. So manually we have to correct it. Also indentation errors also we have to correct it. We cannot handle it. So if definition test, so what I'm saying, definition test, and I'm not giving any indentation here, you notice it, the print statement directly comes below the definition statement, that is function statement. So what it says, there is an indentation error. So how do I handle this now? So I have to give four spaces after the definition. So four spaces, one, two, three, four. I have given the four spaces. Now if I run it, it does not give any error. So for these kind of errors, we have to correct it manually. Now next we have name error. So, what is a name error? It occurs when you try to use variable, function, or object that has not been defined yet in your current scope. For example, I'm trying to print the value of x, but I have not defined the value of x. So, it says name error. Name x is not defined. So, similarly, for variables, for functions, for objects, if you try to use these without defining it in its current scope, then it will error out. So how do handle those kind of exceptions? So I'll try this in I'll put this code in try block, then catch that exception. Caught. Name x is not defined. So instead of program crashing, We are exiting gracefully through by providing message to the user. Then we have type error. What is a type error? It occurs when you try to perform an operation on incompatible data types, such as adding a string and integer. So, can we add in a string? One plus a, can you add? uh, we cannot add, so it's not a number, so we can add number with number, we cannot add number with string. So those kind of scenarios here you can see. So when I try to add string, this is my string 2 plus 2, so this is my string data type 2 and this is my integer data type 2. It says type error, can only concatenate string, not int. So here it's saying the reverse. Since we have put the string at first, it's trying to concatenate. Now, if you put 2 first, then it will try to add unsupported operand. So it says you cannot add string value with integer. So for this, what you have to do, we can put this risky code, these type of risky code in try block, then catch that error and exit the program gracefully. Cannot concatenate string with integer. Or if I add 2 plus, so it will say cannot operand, cannot perform this operation with integer and string to add the number. Next, we have value error. So value error happens when a type of input is correct, but the value is invalid or inappropriate options. So we have already seen this in the starting of the program. So what is value error? So when the user inputs incorrect value, then value error occurs. So instead of integer, he has put the string, then the value error is raised and we have caught the value error and displayed the message here. Okay, so there are certain scenarios like if a user is trying to divide by 0, then division by 0 will error will occur. So this is an exception. So how do we handle these kind of exceptions? We'll catch that in except block. Division by 0 as e, print cannot divide by 0. So we can write this program, this is division by 0, that's why you have to provide the uh, denominator as some number greater than 0. Index error. So let's say I have indexes in my list 1, 2, 3, but I'm trying to access a list index that does not exist. So what does it say? It says index error. So to handle these kind of errors and exit our program gracefully, I'll put this risky code in the try block, and in the except block, I'll catch that index error and we can run it. So it says caught. So we have caught the exception, it says list index out of range. Similarly, we have other type of error, key error. So what is a key error? So we have already seen dictionaries. So how do we access dictionary? So we access dictionary using keys. So now here I have name key, but I don't have age key. But I'm trying to access age key even though it does not exist. So what do I get? I get the key error. So to handle these kind of errors, I can put that risky code here in the try block, and I can prevent my program crashing, and so that I can exit my program gracefully by giving a message that you're trying to access invalid key. Okay, so next I have attribute error. So what is an attribute error? It occurs when you try to access or call an attribute, method, or variable that does not exist. For example, I have x is equal to 10. So I'm trying to append x f5. So x integer. So integers are immutable data type. So we cannot append 5. We can add it. So for these kind of errors, I put that risky code in the try block and catch that error. Okay, int object has no attribute append. Next, we have import error. So you might have noticed initially we have installed Jupyter Notebook using pip install. So there might be some scenarios where we might not have the module existent in our system. So in those cases, we'll get this error called import error. Okay. So why does it occur? The module does not exist. The name does not exist. Might be we are entering the wrong name of the module, or there's a typo or the system issue, path issue. Okay. So let me run this. So from math import cube. So what it says, import error, cannot import name cube from math unknown location. So that means there might not be any cube module inside the math module. So that's why it's erroring out. So we'll put that risky code in the try block and catch it. Cannot import cube from math. Then we have module not found error. Uh, so your module name might be perfect, like import pandas, import numpy. The name might be perfect, but it's not. It's still not installed in your system. So for those cases, here you can see module not found error. So for those kind of cases, first we have to do pip install. So whatever the module name is, okay. So, uh, if you do not want your program to error out, you can put this risky code here in your try block and catch that exception, and so that you can prevent your program to crash. So here we have caught what we are seeing: no module name, non-existent module. So just have just given a sample name which is not real. Okay. So to handle these type of errors, we have to first install module name using pip install command. So next we have IO error. Okay, input output error. So what is IO error? So it's a general error for any input output operation, not just files. So like it covers files, network streams, devices, IO failures, all of those. Okay, so even the lack of permission, if the file is locked, the disk, even the disk failures, all those, the IO error will cover. Okay, so let's say I'm trying to access a folder that I don't have access in the read mode. So it will say file not found error. So uh, here I'm accessing a file which does not exist actually, but all those messages that come with file related, it will be file not found error or IO error. So I have to catch these type of error in IO error. So here you can see even my exception type is file not found error. What I'm giving, IO error. So IO error is the main top level error. Inside that we have multiple errors. So if you define this top level exception type also, it will catch that this type of exceptions that are no related to it or under it. I'll show you. For example, here exception OS error and IO error. So these are at top level. So whatever comes inside it is file not found error, permission error, I is Active Directory error, not Active Directory. So instead of directly selecting file not found error, if you just give the parent name IO error or OS error, then also it will work. So that's what it means. So instead of directly giving file not found error, I gave the parent exception type, that is IO error. Then we are able to execute the program gracefully. But the best practice is to give the exact error exception type so that we can handle our program gracefully. Okay. So next, file not found error is a subtype of IO error, which all we have already seen. Okay. Now let's catch the file not found error directly. So here I have run my program with open file, no file.txt, and I'm trying to read the file. So the file does not exist in my system. So it raises an exception type file not found error. So now I'll catch this exact exception type into my risky code. I'll try this program into my risky code, and I'll try to catch this exact exception type in except clause. Now let's see it run. Okay, let me run this. Okay. Okay. So this has run and it has catched the exception. So even you can replace this file not found error with your top parent exception type, which is IO error. So if you replace this with IO error also, it will work. Okay, so there is a spelling IO ER dash R. Okay, so it's a case sensitive. I have to write it properly. So this will also work out, and this will also work. So IO error is parent exception type of file not found error. So hope this is clear for you. Next we have OS error. So even OS error is again the parent exception of IO error. Okay, so uh, let's say I'm importing an OS built-in module. I'm saying remove file, but the file does not exist. The file that I want to remove, that does not exist in my system. I gave the dummy file name. So what is the error it generated? File not found error. So what is the exception type I'm giving? OS error. Still, it catches that type of error and says caught Windows error 2. The system cannot find the specified file. A file does not exist. So it gives the detailed message. Even though I did not use file not found exception directly, I used the very high level parent type exception. It worked out. So this is the hierarchy of IO error and OS error, under which we have file not found, permission error, all these. Okay. Okay. So why do we create custom exceptions? So we are already seen built-in exceptions, and we have already seen how to handle them. So why do we create custom exceptions? So we might have different requirements. We have to create custom logic. So in those cases, creating custom exceptions and raising them will help us to log the errors properly, and will differentiate between different kinds of problem that might occur in our program, and it provides more meaningful message to the logic. For example, here you can see class my customer exception. So here you're just saying pass. That means do nothing here. Then I'm writing a function check number. If x less than 0, raise negative numbers are not allowed. So let me try this program. So I'm passing a negative number here. You can see custom error, negative program or not. So here it makes more meaningful, and program does not crash, and it's readable also. Okay. So, where these kind of custom exceptions will be useful, like for example, you're doing a form validation, like you're checking whether invalid email address have been entered. So, in those case, you can raise invalid email error. So, if there is a business rule enforcement like insufficient fund error, API design. So, while designing API, so whenever you call an API, it hits the server. So you can limit how many hits on the server uh, can happen, can user perform. So if it reaches that threshold, like someone is accessing the API even after 1,000 times, you can say rate limit exceeded error, internal checks, the data not found error. So all these custom exceptions which are not defined in build, you can build by yourself. Yeah. So next we have some of the practice samples. So you can try all of these and see how we handle exceptions in real life. So these are the some of the exercises. So I will run two of them. Like I'm trying to open a file, and I do not want my program to crash if that file does not exist. So what I say, write my accept clause and say file not found. If the file is not there, then finally block is just a placeholder. Say is execution completed. It will release all the resources of the program that we ran. So again, one more we have like x is equal to -1 and raise value error. So want to raise a value error if it's a negative. If the value entered has been negative, then we want to catch that value error. So you can write in try block. So even you can raise error and you can catch error. So you can write this program, continue to write this program and catch the exception and exit the program gracefully. Okay. So, uh, so in short, uh, what we have seen how to do error handling and exception handling in Python. So, whenever error handling and whenever errors or exceptions occur in programs, Python programs, it stops the program. So, in order to prevent the Python program uh, exiting uh, and crashing, we want to exit the program gracefully. For that, we use exception handling. So there are various built-in exceptions. We can write our own custom exceptions also for logic, custom logic building and proper messaging and logging the messages. Okay. So uh, here is the syntax that we have seen. So it starts with try, where you can put your risky code that might error out. You can catch that exception with except clause and writing what is the exception type. And then finally block, like it always runs by default. If you do not mention anything, like by default, it's a pass statement. Okay. So that's it for today. So I encourage you to go through these exercises and see yourself by executing these exercises. And if there is any error that occurs, you put that in try, accept, and finally block and exit the program gracefully. Okay. Thank you very much. We'll meet next time. Bye bye.